All right, so we are ready to go ahead and begin our next section. We are in section 1-7 for Algebra 1. We did skip quite a few sections because they are so much review that we didn't think that they were really worthwhile to cover again. It just covers things like addition and subtraction and that type of stuff. So we are getting into the distributive property and combining like terms. And once again, these two skills are going to be used over and over for the rest of the year for algebra. So let's get started. First of all, what is the distributive property? Well, it's used to simplify the product of a number and a sum or difference. So first of all, it's important we're noticing the word product in there. So we are going to be multiplying with this. And to kind of put it in layman's terms, the way I say it is multiply to everything within the parentheses. So that's basically what you're doing. Now, when we are solving stuff like this, it can be written a lot of different ways. So here we have a number multiplied by two things that are added together, and it's in the front. Over here, though, that number is written in the back. It's still the same thing. We take this A and we multiply it by the C and we multiply it by the B, getting us B times A and C times A, which is over here. It also works the same way if you have subtraction on the inside of your parentheses, and it doesn't matter how many times or how many things are inside of this set of parentheses. Whatever is inside of it, you give that A or that number to everything. That's important, everything. So let's go ahead and look at a couple of examples with this distributive property being used. It says, what is the simplified form of each expression? So notice we can't solve for anything because we don't have an equal sign. We're just simplifying it. So we're going to take this 3, and because when two things are right next to each other, like this 3 is right next to that set of parentheses, that means multiplication. So this 3 needs to be multiplied by the x, and this 3 needs to be multiplied by that 8. Well, 3 times x is 3x. To know what sign goes after that, carry down whatever sign you have. So we have plus 3 times 8, which is 24. And we are done. We can't simplify this anymore. So 3x plus 24 is our answer for that. Okay, now we have -7 in the back of our expression. That's okay. We're going to still solve it the same exact way. So we're taking -7 and we're multiplying it by 5b, and then we're taking -7 and multiplying it by 4. Well, a negative times a positive is going to get me negative. So I have -35b, carry down your minus sign, -7 times 4, that's going to be -28. Now, let's go ahead and go one step further. We know that when we subtract a negative number, that actually turns into adding a positive number. The negatives kind of, quote unquote, cancel each other out. So we have -35b plus 28 for that final answer. All right. We can also use the distributive property when we have fractions. Remember, a fraction bar works like a grouping symbol. So I'm going to write that out one more time. Fraction bar is a grouping symbol. So when you have more than one item in the top of your fraction, you're actually able to distribute the bottom out or rewrite it like it were distributed. So this broken heart method, you can think of it like drawing a heart around the terms. and now it kind of looks like a heart, and we're going to break it in half. So we have 7x over 5. Where do I get my sign? I'm going to look at this sign right here, which is a plus sign, plus 2 over 5. And we're good to go. This next one, I have 3 terms in the numerator. Well, we can still use the broken heart method, but since we have 3 terms, it's not going to look quite so much like a heart like it does here, but it's still the same concept. We can divide it up like this, and notice the bottom is in all 3 of these kind of loops. So my first one is 4x over negative 3. Where do I get my sign? Right here, and it's a plus sign. Plus 5y over negative 3. Minus, because I have a minus right here, minus 1 over negative 3. I did not change the value of these. All I did was rewrite them in a different way. So that also means we could recombine them into one term or one single expression like these guys are. All right, for C, what I want you to notice with this one is instead of there being only 1 term in the denominator, there's 2. That means if we tried to do this broken heart, then it would be upside down like this. That should be a clue for you that you cannot simplify. So this one we can't do anything to. When you're adding and subtracting fractions, the bottoms always have to match. And that's what we did for these 2 problems, A and B. We kept the bottoms the same. Well, here, if we tried to split that up, one bottom would have 2x and the other would have 8, so that wouldn't match. So that's why we can't simplify this at all. In our try it problems, we have 8x minus 2 over 4. Well, let's go ahead and form our heart. We have 8x over 4 minus, because of my minus sign, 2 over 4. Now what I hope that you notice is that these are all even numbers, like 8, 4, 2, and 4, they're all even numbers. So this can be simplified a little bit more. 8 over 4 is the same thing as 2x over 1, because I divided a 4 out of the top and bottom of that fraction. Minus, and we know that 2/4 is the same as 1/2. So I'm going to rewrite it like that, simplifying it. I did not change the value. Once again, all I did was just reduce my fractions. So that would be 2x over 1 minus 1/2 for that answer. All right, what if you are distributing a -1 across the parentheses? Here we have an example where we don't see the -1, but we just see a minus sign in front. Don't let that confuse you, thinking that that's just minus 2y. Actually, there's an invisible 1 here. As you guys know, a lot of times we don't write 1 in math, but it's implied to be there. So now we have -1, and we need to multiply it across the parentheses. So -1 times 2y is -2y. And then minus, carry my minus over, -1 times 3x is going to be -3x. Well, now I have minus a negative sign, so I'm going to be able to turn that into addition. My final simplified is -2y plus 3x. And that is option C right here. So I'm just going to fill that in, and I'm good to go. There's no difference of using the multiplication property of -1 when it comes to the distributive property. The only thing I see people doing is they forget that it's there because they don't see the 1 or some number, so then they like ignore it or something like that. So if it helps you, you can write in that 1 to remind you to distribute it across the parentheses. All right, let's do the back of these notes real fast, and then we will be done for today. So in problem 4, we're going to be using a little bit of mental math. The distributive property is really helpful if we need to do something quick and in our head. So here's our problem. It says deli sandwiches cost $4.95 each. What is the total cost of 8 sandwiches? Use mental math. Well, I am going to write a little bit of stuff down. I know that's not what mental math is, but I want you to be able to kind of see my thought process. So we know right off the bat we're getting 8 sandwiches. And what we can say to ourselves is $4.95 is really close to $5. It's only 5 cents away. So we can temporarily pretend like these are $5 so we can easily multiply 5 times 8. So I'm going to do that, and I'm just 5 times 8, and we know that's $40. Okay. Now this $40 is a high estimate because the sandwiches are actually $4.95. So I need to take away the extra stuff that I added on so I could do this more easily. Well, I added 5 cents per sandwich essentially. So I've got 5 cents and 5 cents and 5 cents 8 times extra. So I can say 5 cents times 8, which is going to be 40 cents. So this is my high estimate, and this is how much extra that estimate is. So to figure out my final answer, I'm just going to take $40 minus 40 cents, which is going to get me $39.60. I know it said use mental math, but that's kind of difficult for me to talk through every single step without writing it down for mental math. So if it tells you to do mental math, then you wouldn't have to show me all that stuff because you're supposed to be doing it in your head. But I'm teaching, so that's why I kind of went ahead and wrote that down. The last thing we're going to talk about today is something called like terms. Once again, I'm going to highlight this because this is really, really, really important. And this is kind of how I describe like terms. Like terms have the same variables in the same amounts. Okay. This is very important. And here are some examples of that. So this 5x and this negative 3x are like terms because they both have x's in them, and the x's are both raised to the first power. It's just not written. So they have the same letter and the same amount of those letters. This has x squared and x squared. Well, they both have x, and both of the x's are squared. Notice over here in this example, though, they both have x's, so the letter matches, but the amount of that letter does not. So this one has 2 x's, or x times x, but this one has x cubed, x times x times x. So that's why these are not like terms. Now, there's one more thing I want you to know. You can only add and subtract like terms. You are allowed to multiply anything you want. So you can multiply anything you want. But to add and subtract, they must be like terms. I'm going to jump down here just to the corner and kind of show you what I mean by that real fast, okay? So let's say that I had 5x times 5y. I'm allowed to multiply these together, and that's going to get me 25xy. I am not allowed to say 5x plus 5y equals 10xy. That's not how that works. So this is wrong. I only can leave them separated like this. Now, if this were 5x plus 5x, well, now I have same letters and in the same amount, so this would be 10x. So with multiplying, it's fine to combine them, but when adding and subtracting, you can't combine them if they're not exactly the same. Let's do a couple of these examples in the notes, and then we are done. So, what is the simplified form of each expression? We don't have anything we can substitute in, so we're just combining these things. We have 8x squared plus 2x squared. You need to look at the number in front of your variables, so 8 and 2, and because I have a plus sign, I add them. 8 plus 2 is 10. Then your variable comes along for the ride, 10x squared. Just leave it the same. This next one's a little bit more complicated. My advice to you is to kind of circle what problem or what terms you're using at the time, or have some type of code for yourself. It doesn't really matter where you start. Also, the sign in front of the number is what you use. One more time. The sign in front of the number is what you use. I'm going to make a note of that actually. The sign in front of each term is what you use. Okay, so I'll just start with x's. I have 5x. It's positive because I don't see anything, so that's positive 5x. And then 3x. Notice there's a minus sign right here, so I'm going to include the sign that is in front of it. 5x minus 3x gets me 2x. Okay, now I'm going to look at my y's. Well, here's positive 6y. I'm using the positive in front of it, so that means plus 6y. Now, I'm just doing my plain numbers, my constants, so negative 3 and positive 4. So negative 3 plus 4 is going to be positive 1. I can't combine these anymore. I looked at my like terms and that's all I have, so I'm done at this point. For my final example, I have 7x cubed minus 4x plus x minus x cubed. All right, let's start with my 7x cubed, and I have an x cubed right here. Remember to include the sign in front of it, which is a minus, and remember there's an invisible 1 in front of that, so if you need to write in your 1, you can. So 7 minus 1 is going to get me 6, and then your variable comes along for the ride, 6x cubed. Now, let's look at my plain x terms. I included the minus sign in front of the 4x, and I included the plus sign in front of this plain x. If you need to write in your 1, you can. So negative 4 plus 1 is going to be negative 3, and then the x is along for the ride. Remember, we cannot combine these because this one is x cubed and this one is just plain x, so it's as simple as it can be. All right, that's it for the distributive property and combining like terms. Per usual, if you don't understand something or have questions, make sure you bring them to me tomorrow when we're doing your practice problems. And until then, have a great night.